We're going to look at some trig proofs, specifically focusing on reciprocal identities and quotient identities in this video. Sine always goes with cosecant, cosine with secant, and tangent with cotangent. So whenever one of those is in the numerator, the other one's in the denominator. Those are the reciprocal identities. Then the quotient identities, tangent is the same as y over x if you think back to the unit circle, so that's sine over cosine, and cotangent is cosine over sine, because that's x over y. The first example is cotangent of x, secant of x equals cosecant of x. So you want to work with the more complicated side first. It's easier to make something complicated simpler than simple more complicated. In this case, that'll be the left side. Another strategy is to try changing everything to sines and cosines. It doesn't always work, but it's a good strategy if you don't know what else to do. So cotangent, if we look back, cotangent can be written as 1 over tangent, but it can also be written as cosine over sine. And if the strategy we're trying is changing everything to sines and cosines, I'm going to rewrite it as this one. Cotangent is cosine over sine, and secant goes with cosine. Secant's in the numerator right now, so cosine's going to be in the denominator. Cosines cancel, we're left with 1 over sine. 1 over sine is cosecant. So we prove that the left side equals the right side. Make sure you show that last step of showing that the left and right equal. The next example is a little bit harder because we're going to be dealing with fractions and fractions. Secant is 1 over cosine. Sine, we can leave as sine. Tangent, in terms of sine and cosine, is sine of x over cosine of x. So we can multiply both the numerator and denominator by the reciprocal of the denominator. So we have 1 over cosine of x times sine of x over 1, which was the numerator, and then times the reciprocal of the denominator, cosine of x over sine of x. And now we can see that the sines are going to cancel and the cosines are going to cancel, and we're just left with 1 over 1, which is 1. So we prove that the left side equals the right.